The question number 6 is that a curved road with the radius of curvature 200 meter is banked with the banking angle equal to tangent inverse 0.2, the optimum speed of the car. Now, dear students, you know that on the banked road, the tangent of theta, the banking angle theta, is equal to v square divided by r into g. R is radius of curvature and g the acceleration due to gravity. And theta, as you have seen, that is tan theta is given equal to 0.2, that is equal to 2 by 10. So I fill here 2 by 10 equal to v square, that you have to find out the optimum speed. The radius of curvature is 200 and g is, let's take 10. So this cancel out. Therefore, v square is equal to 400 and v will be the root of 400, which is equal to 20 meter per second. That's the optimum speed. So the option is the first one to this question. Let's move to the next problem. The question number 7 says that how much work is done by the force F equal to 3x I cap plus 4j Newton with x in meter that acts on the particle as it moves from the coordinate 2 meter, 3 meter to another point 3 meter, 0 meter. Now, dear student, it is the variable force and it's acting in 2 dimensions. Therefore, the work done you will calculate by the method of integration, and this would be like fx dx plus fy into dy. Now we'll dig out fx and fy. Now fx is 3x in the given question and x goes from 2 to 3 dx, and now for y is 4, which is constant, into dy, and y start from 3 to 0. So we to integrate, so 3 is taken out and this is x square by 2 and the limits are from 2 to 3 plus 4 is outside and this is y and limit are from 3 to 0. So 3 by 2 is outside and that means 3 square minus 2 square and plus 4 and 0 minus 3. So this is 3 by 2 into, and this comes to 3 square 9 minus this is 5 and minus 12. So 15 by 2 minus 12 and that is minus 4.5. So minus 4.5 joule should be the work. And the first option is minus 4.5 joule. So answer to this question is the first option. The question number 8 is a block whose mass is 5.7 kg slides on horizontal frictionless tabletop with a constant speed of 5 meters per second. It's brought momentarily to the rest by compressing a spring in its path. Well, what maximum distance is the spring compressed? The spring constant of the spring is given 1282.5 Newton per meter. Now, dear student, it is given that this block is moving on the smooth surface with the speed of 5 meters per second. Now, what will happen as this move forward? So there will be one situation when it is losing its kinetic energy and it has compressed the spring fully, like this one, and this block has come to rest. So you can see that whole of its kinetic energy has been converted to the potential energy of the spring, and spring has moved through a distance of x. And that's the maximum compression. Now later what will happen? The spring will push the block backward. So use the mechanical energy conservation, that potential energy gain is equal to kinetic energy loss. Now how much kinetic energy is lost? 1 by 2, the mass of the block and velocity square. This is the kinetic energy loss. And what is the potential energy gain? 1 by 2 k into the maximum compression of the spring when this velocity is 0. So we have to solve this, the maximum compression. So xm, so half cancel with half, and that is equal to m by k root into the velocity. So xm is equal to m. The mass of the block is 5.7 and the k was given 1282.5 root multiply with the velocity is 5 and this cancel with 2 to 5. So that is equal to 1 by 2 to 5 means 1 by 15. The root of this into 5. So 5 by 15 is 1 by 3 meter, which is 0.33 meter. So 33 centimeter is the correct option. So answer to this question is option number 4. The question number 9 says a constant power is applied to a car of mass 3000 kilogram. The velocity of the car increases from v equal to 2 meter per second to v prime equal to 5 meter per second when the car travels a distance of 117 meter. The value of power p. Now dear student, the speed is changing and let's go to the formula power, which is constant, which is equal to force into velocity, that is equal to mass, acceleration, velocity. We have to find the relation between v and s. So mass and velocity, I write v dv by ds into v, that is equal to m v square dv by ds. Now to get the value of p, so that means p into ds is equal to mv square into dv. So we'll integrate on both sides. P constant goes out and this is the distance and this is m and v square means v cube by 3 and from v to v prime and that is equal to m by 3 and v prime cube minus v cube. So p you have to find out. So p is equal to what? Transfer s to this side, m upon 3s and v prime cube minus v cube, right? We have to fill the values. The mass is 3000 and 3 into s, the distance travel is 117 and v prime, that means 5 cube minus 2 cube. So this is 117, so this cancel with this and you're left with 3000 by 3, which is equal to 1000 watt. So the correct option is 1000, or the fourth option. So answer to this question is 4. The question number 10 is a particle of mass m begins to slide down a fixed smooth sphere from the top as shown. What is its acceleration when it breaks off the sphere? Now dear students, as this mass is going down, its speed is increasing and when its speed increases, then you can see logically the centrifugal force is increasing and somewhere it's losing contact. And the condition is when it loses contact, then the normal reaction becomes 0. And when the normal reaction is 0, so it's just like a free fall. So the acceleration in that case of this body is equal to g. And therefore the answer to this question is 3.